In this presentation, I will talk about an overview of provision mitigation against memory corruption attack. This paper has been done by Mahmoud Jassim Khalsan with Michael Apoko, Department of Computing, University of Northampton, UK. The main purpose of this paper is to help researchers to find out the techniques that used by attacker to attack memory corruption, as well as there is some techniques against them. Let us start with list of contents, introduction, buffer overflow, the current techniques against memory corruption attacks, and conclusion. Introduction. In the past 2 decades, memory corruption attacks have captured the attention of security research community. The first organized swarm that exploited a memory corruption attack to spread itself was called the Mori swarm. This kind of attack is well known for its high exploitability that allows the attacker to simply execute arbitrary codes. It takes control of the remote code execution according to the latest Microsoft report. Buffer overflow can be defined that it happens when data size reaches to the out of bounds of the memory. So based on that, we have lots of techniques have been utilized to prevent or mitigate. Here we have stack relied buffer overwritten attacks, heap relied buffer overwritten attacks, a block started by sample relied buffer overflow attack, other hacking techniques, relevant buffer overflow. Let us start with stack relied buffer overwritten attacks. We produce that how attackers can exploit a stack-based buffer overflow. As we mentioned previously, that a buffer overflow occurs when the input data size is that should be handled by buffer is larger than the size of buffer itself. In another word, can be described as it happens when insufficient boundary checking. Heap relied buffer overwritten attack is a kind of buffer written. It occurs once a chunk of memory is assigned to heap. Also, data is typing to this memory with no limitation of checking the size of the data that have been written. Honestly, this vulnerable allows attackers to overwrite some important data structure in the heap, for instance, the heap header. And we have a block started by sample relied buffer overflow attacks. The whole idea of block started by sample BSS is any program start running all variables, either local or global, which aren't assigning value as initial, or these variables initialized with 0. For these variables, BSS will generate automatically. Consequently, the BSS area result buffer override in the buffer which has been created as BSS area. Subsequently, the BSS area can be exploited by some attackers to overwriting some data. Other hacking techniques relevant buffer overwritten. One of these format string exploit. The vulnerabilities of this kind of techniques are resulted by incorrect invocation of some of function like printf, sprintf, and others. Attacker can exploit that by entering incorrect data for the first parameter of the printf function, as we expect that first parameter has to be printf 100% s and buffer. To clarify that, an example has been used for this purpose, can be seen in the paper. Other hacking, we call it numerical handling. The problem of numerical treatment that when we do incorrect math operation or numeric conversation, numeric handling includes integer overflow, or particularly they are utilized with buffer overflow attacks. In this part we explained the vulnerabilities that can be exploited by hacker. Here we have list of techniques that have been used to prevent or mitigate memory corruption attacks. First of all, started with operating system. We have 4 techniques are used to prevent attackers to attack memory corruption attack. First of all, data execution prevention. Secondly, we have armor and address space layout normalization, kernel address space layout normalization, and we have other techniques with compiler and linker, like compiler options, GCC compiler options, and detection, address, synthesizer, stack, smash, protector, automatic fortification, stack, shield, protection, other techniques against memory corruption attacks. Starting with operating system, data execution prevention. This technique is used for force the memory to be writable with no possibility to be executable, or it is executable but must be read only, such as code segments. Armor has been used to avoid block start. Attackers copy malicious code into memory. Address space layout normalization. The main aim of that is to prevent attackers of executing shelled code in stack area or heap area. Additionally, shared libraries by normalizing them. Kernel address space layout normalization. This mechanism attempts to normalize both program and data locations in kernel area with the kernel startup. Other techniques that we have: GCC compiler option. In this section we have integer overflow to buffer overwriting. It occurs when the output of any calculation, such as multiplication or dividing by 0, is surpass the range of the data type. Is one of the most common vulnerabilities that used by attackers, as illustrated previously in vulnerabilities in numerical. Other techniques we have used: address citizen. It used to detect 6 types of ways that used by attackers to hacking memory. The 6 types can be listed as following: out of bounds, use after free, use after return, use after scope, double free, invalid free, and memory leaks. Stack mashing protector, it utilized to detect that the return address that has been modified before the function returns by inserting canary word underneath return address on the stack. And last one, we have automatic fortification. It used to prevent format string attacks that explained previously. And we have compiler and linker as well. We have stack shell protection. The key idea is to copy the return address and keep it in somewhere that shouldn't be overflow memory space at runtime. Other techniques against memory corruption attacks: instruction set normalization. It uses to prevent return or oriented programming attacks. And we have pin. It used to defense against return address. It works as following: when the program starts running, it is potentially analyzes and create binary translation for the code that has been inserted by user. And finally, we have conclusion. In this paper, we highlighted most common techniques that can be exploited by attackers to hack memory. Additionally, we present existing countermeasures that have been used to prevent or minimize memory corruption attack.